Graphing quadratics in vertex form. Okay, so it says the first form of quadratics functions you learned about was called standard form, written in the form of f of x equals ax squared plus bx plus c. The second form of quadratic functions is called vertex form. So this is what vertex form looks like. It looks like a parentheses x minus h squared plus k. So it doesn't have like in standard form. You remember standard form had this A, B, C sort of format. So this vertex form doesn't have that. It still has an A, which determines whether or not the parabola opens up or down and how steep it is. But it doesn't have that B and C stuff. But what it does have, which I love vertex form for this, is that this HK represents the location of the vertex. So vertex form is so great because it gives you the vertex. You don't have to do that negative b over 2a substituted into the equation to figure out the location of the vertex. It just straight up tells you, which is great. So here's a few notes for you here. It says the y-intercept. In order to get the y-intercept when the function's in vertex form, it's no different. You plug in 0 for x. We've been doing that quite a bit. X-intercepts, you plug in 0 for y, and then you're going to have to solve with some steps. The vertex, like I said, is given by the equation, and that axis of symmetry is the x-coordinate of the vertex. And we touched on that a bit in the last unit because remember, the axis of symmetry goes through the vertex. Okay, so let's jump in on this first one. It says graph the following quadratic function by finding the key features. So I'm actually going to go ahead and get the vertex first because it's in vertex form. So it's really easy and nice to pull out the vertex. Now, when you're looking at this vertex form, it's a little similar back to when we were working with point slope form in the linear functions. It's so HK is the vertex. Now, if you look at this function, it's minus H, which I like to sometimes say opposite of that number in the parentheses, opposite H, and then whatever K is. That's the vertex. So on number 1, the vertex is positive 5, negative 32. Positive 5, negative 32. It's opposite of this, and then that value. But it's not the opposite of the negative 32. It's still negative 32, and that's where you get a little confused. You gotta remember, it's opposite what's in the parenthesis here, and then this value. So positive 5, negative 32. So I'm going to go ahead and plot that vertex now. 5, negative 32. That would be around here. Okay. And the great thing is once we have the vertex, we know where the axis of symmetry is, right? Because the axis of symmetry goes through the vertex. No solving required. So I'm going to draw a little dashed line. So that means the axis of symmetry is at 5. At the line x equals 5. Remember, these will always match up because the axis of symmetry goes through the vertex. Now the y-intercept, we're going to plug in 0 for x. Yeah, so here we go. 2 parentheses 0 minus 5 squared minus 32. So you're going to notice, unlike standard form, like a bunch of stuff doesn't just cancel out. Remember in standard form when you plugged in 0, those first 2 terms just canceled out to 0. This isn't the case. Now we have to use some order of operations here. So 0 minus 5 is negative 5. So I'm going to have 2 negative 5 squared. Negative 5 squared is positive 25, right? So I'm going to have 2 times 25. 2 times 25 is 50. And 50 minus the 32 is 18. So this y-intercept is at 0, 18. Okay. So that would be about here. Now, before we continue, let's just get the roots. Okay, so we got the y-intercept. We got the vertex. Now we need the x-intercepts. We need the roots, the zeros, the solutions. Those are all synonyms for x-intercepts. So remember, we plug in 0 for y in order to find the x-intercepts. So I forgot the equation. 2x minus 5 squared minus 32. Okay. Now, this we're just going to have to use kind of solving steps. This isn't in standard form, so we can't use the quadratic formula. There's no ABC in Vertex form. There's no, you can't factor it right now the way that it's written. So we're going to just kind of do some solving steps. So these are the steps that you need to do. So we're solving for x. So the first step we would do would be add 32. So you have 32 equals 2 parentheses x minus 5 squared. Now that 2 is being multiplied to that entire quantity of x minus 5 squared. And I know your first instinct would be to distribute, but you actually can't do that because of that squared up there, that second power. You can't distribute into a parentheses that has a squared on it. So, but since that entire quantity, x minus 5 squared, is being multiplied by 2, we can divide by 2 on this side to rid ourselves of that. And now, since we have 16 equals x minus 5 squared, in order to start solving for x here, we're going to take the square root because the entire quantity x minus 5 is being squared. So I'm going to take the square root. So now we just have an x minus 5 that gets rid of the squared. And when we take the square root of 16 in solving, remember the square root of 16 is 4, but when we're solving, not only 4, it's positive or negative 4, plus or minus 4. And then add the 5 over, and then we have isolated x. Now remember, for math notation, typically we're going to write the 5 in front. You could write plus or minus 4 plus 5, but usually you put the 5 in front. 5 plus or minus 4, that's usually how the math notation is. So x equals 5 plus 4, and x equals 5 minus 4. So it would be 9 and 1, but I'll write that out. Again, what I'm saying, x is 5 plus 4, which is 9, and x is 5 minus 4, which is 1. So those are the roots at 9 and 1. So we can kind of draw a nice little parabola here. But before I draw that parabola, I'm going to try to draw a nice little symmetrical point for my y-intercept. So it looks like it's 5 lengths to the, yeah, it's like 5 lengths to the line there. So I'm going to try to draw just so that I have a nice one. There's a symmetrical point there. So yeah, just to make sure it looks as pretty as I can make it. Yikes, it's not that pretty, but whatever. Okay. Yeah, why did I drew it so bad right over here? Okay. Okay. So that's how you deal with vertex form. So just to recap here, I love vertex form because it straight up gives you the vertex. Opposite of what's in the parentheses, and then for your x coordinate, and then whatever's on the outside there for your y coordinate. And of course, the axis of symmetry goes through the vertex, so that's very simple. The y-intercept, just plug in 0, and just, do the math, get the y-intercept. And then for the x-intercept, that's a little bit more steps. You plug in 0 for y, and then there's kind of set solving steps that you need to go on from there to find the x-intercept. So let me show you another one. Okay, same thing. Now, this one, just so that we're clear, maybe I'll go scroll it back up here. You see, when you kind of check your answers, see this one had a leading coefficient of 2. So it was positive 2, so it's opening up. This one's got a leading coefficient of negative 3, so I know this is going to open down. But that's kind of beside the point right now. But when we finish the problem, maybe we should check to make sure that our parabola looks good. But anyhow, like I did on the first one, I think it's most appropriate to get the vertex first, right? Because it's right in the equation. It should be pretty quick. So it's opposite of this number in the parenthesis. So we're going to have negative 1. And then whatever this number is, which is a positive 12. So it's only opposite of what's in the parenthesis. So I'm going to plot that. Negative 112 here. And remember, the axis of symmetry goes through the vertex, right? Goes through the vertex. So it should be at -1. Goes through the vertex. Okay, so I know it's going to be symmetrical about that, and it's probably going to do some it's going to open down, right? Because of negative coefficient. So look at that. We already got 2 out of the 4 key features that we need. This is great. So now let's get the y-intercept. Get the y-intercept. We plug in 0 for x. Um, 0 plus 1 is 1. 1 squared is 1. Negative 3 times 1 is negative 3. And negative 3 plus 12 is 9. I know I did that too fast. Sorry. So the y-intercept would be at 0, comma 9. So let me plot that. That would be about here. And that makes sense. It should be below the vertex because this is going to open down. Now let's get the x-intercepts, aka the roots or the zeros. So we plug in 0 for y, which is, basically f of x in this situation. Okay. And then we do some solving steps. I'm going to zoom in here. So my first step in solving for x is I'm going to subtract this 12, get that out of here. Negative 12 equals negative 3, parentheses, x plus 1 squared. Now I have this coefficient of negative 3 in front of my x plus 1 squared, so I have to deal with that. There won't always be a coefficient, but in this case, on the previous case, there is. So I need to divide by negative 3 to get rid of that. So now I have positive 4 equals x plus 1 squared. I'm solving for x, right? So I'm going to take the square root because the quantity x plus 1 is being squared. So to undo that, the inverse operation, take the square root. So now I'm left with an x plus 1. The square root of 4 is 2, but remember when we're solving quadratic equations, it's not only 2, but it's plus or minus 2. And then I'm going to subtract the 1 to isolate x. And like I've said before, I'm going to put that negative 1 in front of the plus or minus 2. That's usually how math notation goes. So my solutions, or my x-intercepts, would be negative 1 plus 2 and negative 1 minus 2. So negative 1 plus 2 is 1. Negative 1 minus 2 is negative 3. But let me write that out. So negative 1 plus 2 is going to be 1. And then negative 1 minus 2 will be negative 3. So we got all the features. Let's plot at, 1 and negative 3. And would you look at that? This is going to draw a nice parabola, that's opening down. It's going to look good. It's going to look like a U. Now, I'm going to draw a little symmetrical point for my y-intercept just so that, my curve can look as good as possible. Okay. All right. Here we go. Not bad. And there we have it. There it is. That's how you graph equations in vertex form. And like I said, vertex form is great because it tells you the vertex. So you've already got 2 out of the 4 key features done. The y-intercept isn't too bad. The x-intercept can be quite a challenge, but that's how you graph them in vertex form. So I'm going to let you do the rest.